Welcome to Pomodoro Joe for Thursday, August 31st, 2023. Today we're doing LeetCode problem 1326, minimum number of taps to open to water a garden. This is a hard problem. There is a one-dimensional garden on the x-axis. The garden starts at point 0 and ends at point n. The length of the garden is n. There are n plus 1 taps located at points 0, 1, so on and so forth, up to n in the garden. Given an integer n and an integer array ranges of length n plus 1, where range is index I, means the ith tap can water the area from I minus the ranges at that index to I plus the ranges at that index, if it was open. Return the minimum number of taps that should be open to water the whole garden. If the garden cannot be watered, return -1. All right, so they show us some spans here. So we're given some ranges. These are taps or water taps. I'm going to call them sprinklers. So we have a range of sprinklers in our garden. So it looks like the sprinkler at 0 can water a range that goes back to -3 and goes forward to +3. The sprinkler at index 1, I don't see a thing that lines up with that, so I don't know how much that can water. Sprinkler at index 2 looks like it can water from 1 to 3. And then 3 can go from 2 to 4, 4, I don't see, oh, it looks like it can only water 4, and 5, oh, I guess 5 can also just do, maybe the colors aren't lining up. All right, so we're given ranges. So the sprinkler at index 2, for example, will be in ranges at index 2, and it will give us, I guess, 1. Yeah, so it's going to tell us 1. So I think the first thing I want to do is convert these ranges where it gives me the sprinkler at the center and it can go forward and backward. Let's just convert that to an entire span. So instead of looking at 2 and going back 1 and forward 1, let's start at index 1 and go to index 3 so we can find that span. So once I find this span, then I just have to find the overlap. Okay. Yeah, this is tricky, this is hard, but I think we can do it. I don't have a ton of time, so let's see if we can do it quickly. All right, so we'll put 25 minutes on our Pomodoro timer and we will get started. So let's see, I'll have some result, set it equal to 0, and we'll return the result at the end. All right, so my plan here, I'll just do a little bit of an aside. So we have some list of sprinklers, this ranges. I'm going to convert these ranges into spans. So typically if I'll have some sprinkler, let's see, some sprinkler here, it's going to be able to water forward and backwards by the same amount. That's what's stored in this ranges here. I want to convert this into just a range where I have like the start and the end. So this way, the sprinkler at the center, I don't have to calculate going forward and backwards. I can just look at the start and the end. Then I just need to look for these overlaps where a new sprinkler will start somewhere before the sprinkler ends. So if I have another sprinkler, hopefully I'll have some other sprinkler start here, maybe not exactly there, but somewhere before this sprinkler's range ends. And then this one will have some end. And then I keep looking for these overlaps. All right, now this sprinkler itself might not actually be within this range. Like, let's say we could have something like this, where the sprinkler itself is somewhere outside the range, but I'm gonna convert these ranges into spans so I can check just where the spans overlap. All right, so let's do this. So first let's create spans. All right, and that's just gonna be an array. And let's see, I'm gonna start it at 0 and go the length of the garden. So these spans will tell me where something starts, where some watering starts and ends. That's gonna be the length of our garden, +1 because this n is the length of our garden. Actually, I don't know if I need the +1. Let's see. The garden starts at 0 and ends at n. But then it says the length of the garden is n. I'm a little bit unsure about this. So let's give us an extra 1 just in case. All right, now we'll have to fill this in. So for every sprinkler, in ranges. All right, so now we can go forward and backwards. So the start of our, I'll call it span start. So the span will start at, let's see, this will be, so I need to have the sprinkler index here. That's right. So I'll have to enumerate. So this will return both the index of the sprinkler and its range. So this is more like the sprinkler position and I guess span, or position and reach. There we go, like that. So the span will start at this position minus the reach. So this is the position of the sprinkler, that's the index, and the reach is the value in ranges. All right, so the position minus the reach, but I only want to go down to 0. I don't care what we water outside of our garden. So maybe I'll do a max here. Yeah, I'll do a max of the position minus the reach, or 0. I don't want to go below 0. Okay, and then the span end. Well, that's going to be the minimum, because I don't care about going outside of our garden at the other end. So this is going to be position plus the reach, or n itself. All right, then my spans at this index, this position, will now equal, I only care about the end, really. So span, oh, actually, no, it's not going to be at this position. It's not the span at the position of my sprinkler. It's the span will start at the span start. And that's going to equal the span end. I think I'll make a note here of what this is, because I don't want to forget. Okay, so now that I've got all my spans calculated and put into my spans array, now I just have to go through keeping track of, let's see, each span, where it ends, and where the next span will end. So the reason I have to do that is I have to know where this span ends to know that the next span has to start before this span ends. And then I have to keep track of where the next span ends so that when I get to the end of my current span, I can swap it out for the next span. Hopefully that'll make sense. So I'll have this current span end. Now I don't really care where it starts, I just care where it ends. And then the next span end. All right. So now I have to check every position in the garden to make sure it's getting watered. So for every position in, let's see, this would be a range of n plus 1. So I go to the end of the garden. Okay, so for every position in my range, I'll have my span start. Let's see, the span start will be this position. So the position will be the point in the garden, but we've also created our spans so that they start at different positions. So the span start at this position, and the span end will equal to our spans for the span start. Or you can say for this position, either way, it's the same thing. Okay, so this gives me a span that starts at this position, potentially if we have one, and it will tell me where it ends. So maybe I should explain this just a little bit. Our current span, we've turned on some sprinkler. We've already chosen it, it's on. That's our current span. It's gonna go from some start point. We don't really care where it starts. We just know how far it can reach. That's what we care about. How far can it reach in our garden? That one is turned on. Now the next span is like the next best option, or maybe I should call it next best span or next optional span. Maybe I'll call it next span option. There we go. So the next span option end. So this sprinkler we haven't turned on yet. We're just looking at our options to find the best option. Now we only need to turn on the next sprinkler when we reach the end of our current span. So we'll keep evaluating sprinklers or spans to find the next best span when we get to the end of this span. Okay, so if we get to a sprinkler, we're going to positions in our garden. So we get to some sprinkler in our garden, where if this span start, if this is greater than our next span's option, so the next span option is just, we have something in mind that we can turn on to reach this point, this end. Now, if our span start for this position is greater than our next potential ending point, that means we've missed a patch of our garden. So we are able to reach this. This is as far as we can reach. Now, if our next span starts after the furthest point that we can reach in our garden, then we've missed a spot. And unfortunately, that means that we can't water this garden. So we have to return -1. Okay, what's the next thing we check then? Let's see if this span end. So we know that this span start is within our range. We can use this sprinkler. So if this span end is greater than, like it's better than our next span option, let's do this. So this span might actually be better. This sprinkler might be better than our current next best sprinkler. So let's just switch that. Our next best sprinkler then will be this span end. Okay, I'll go over this one more time. So if this current sprinkler starts watering after the farthest point that we can reach so far, then we can't water. There's some patch of garden that we can't water, so we have to return -1. Okay, now if this current sprinkler, if it can end at some point that's further away than our best option so far, then we'll just swap it out. Instead of using the sprinkler that we had chosen, we'll use this sprinkler as our next sprinkler to turn on. So we'll set our next span option end to this span option end. And finally, we need to know, when do we turn on that next sprinkler? So if our span start, so this current sprinkler, if this is greater than our current span's end, okay, so we're somewhere after our current span, but we are before the next span option end, so we basically run out of our current span. We need to turn on our new sprinkler. So at this point, we need to set our current span end. That's going to equal our next best option. We're swapping or stopping our current sprinkler. We're swapping over to the next one that we've chosen. And at that point, we do have to turn on a new sprinkler, so we increase our result by 1. Oh man, I am so low on time here. Let's submit this and see how we do. And we don't pass. Of course we don't. Why should we pass? All right, 1326, take 2. As you can see, I failed miserably at this one. So let me run this really quick. I'll show you. I was failing. I think my approach is sound though. I think my implementation is bad. I had to go offline and do a little bit of looking here, and I think it's right here. I missed an R. It would run, but it would give me the wrong result. Let's try this. And that works. All right, let's submit that. And it works. Oh, typos, you're killing me. And we do really well, holy smokes. We beat 93% for runtime and 47% for memory, so that is an awesome solution.